Hello everyone, and welcome back to our channel. Today, we're diving into the fascinating world of one of the 20th century most brilliant and enigmatic physicists, Erwin Schrödinger. You've probably heard of his cat, but there's so much more to the man behind the famous thought experiment. So, who was Erwin Schrödinger, and why is he so important to the story of science? Let's find out. Born in Vienna, Austria in 1887, Erwin Rudolf Joseph Alexander Schrödinger grew up in a cultured and intellectual household. His father was a botanist, and his mother was the daughter of a chemistry professor. From a young age, Erwin showed a remarkable aptitude for a wide range of subjects, from ancient languages to mathematics and physics. This broad intellectual curiosity would become a hallmark of his entire career. He attended the University of Vienna, where he was deeply influenced by the physicist Franz Exner and, especially, Friedrich Hassenerl, a brilliant mind who was an early contributor to the concept of mass-energy equivalence. Schrödinger's early scientific career was interrupted by World War I, where he served as an artillery officer on the Italian front. After the war, he held various academic positions in Germany and Switzerland. This was a period of intense intellectual ferment in the world of physics. Einstein's theory of relativity had already shaken the foundations of classical physics, but an even stranger and more profound revolution was just beginning: quantum mechanics. Scientists like Max Planck, Niels Bohr, and Werner Heisenberg were developing a new and bizarre set of rules to describe the world of atoms and subatomic particles. It was a world where particles could also be waves, and their properties were governed by probability, not certainty. Schrödinger was initially skeptical of some of these new ideas, particularly the concept of quantum jumps, the idea that electrons could instantly leap from one energy level to another without passing through the space in between. He felt there had to be a more continuous wave-like description of what was happening. And so, in a burst of creative genius during a holiday in the Swiss Alps in late 1925 and early 1926, he formulated his masterpiece, the Schrödinger equation. This equation is one of the cornerstones of modern physics. It describes how the quantum state of a physical system changes over time. Unlike the discrete, jumpy picture of early quantum theory, Schrödinger's equation treated electrons and other particles as waves, described by something called a wave function. The equation allows scientists to calculate the probability of finding a particle at any given point in space. It was a revolutionary achievement, providing a powerful and elegant mathematical framework for the new quantum world. For this groundbreaking work, Schrödinger was awarded the Nobel Prize in Physics in 1933, sharing it with Paul Dirac. But here's where the story gets really interesting. Despite creating one of the most important tools of quantum mechanics, Schrödinger himself became one of its biggest critics. He was deeply uncomfortable with the interpretation that was becoming standard, known as the Copenhagen interpretation, championed by Niels Bohr and Werner Heisenberg. This interpretation said that a quantum system, like an electron, doesn't have definite properties, like a precise position, until it's measured. Before the measurement, it exists in a superposition of all possible states at once. To Schrödinger, this was absurd. He famously said, "I don't like it, and I'm sorry I ever had anything to do with it." To illustrate what he saw as the ridiculousness of this idea, he devised his famous thought experiment in 1935. You know the one, Schrödinger's cat. Imagine a cat placed in a sealed steel box. Along with the cat, there is a tiny amount of a radioactive substance. The amount is so small that within 1 hour, there's a 50% chance that one atom will decay, and a 50% chance that none will. If an atom decays, it triggers a Geiger counter, which in turn releases a hammer that smashes a vial of poison, and the cat dies. If no atom decays, the cat remains alive. Now, according to the Copenhagen interpretation, until we open the box and observe the system. The atom is in a superposition of both having decayed and not having decayed. Therefore, the Geiger counter is both triggered and not triggered. A poison is both released and not released. And the cat is, and this is the crucial part, both alive and dead at the same time. Schrödinger didn't believe a cat could be simultaneously alive and dead. His point was to show that if you take the rules of the quantum world and apply them to a large scale, everyday object like a cat, you end up with a result that is completely nonsensical. He wanted to highlight the philosophical problems at the heart of quantum mechanics and the mystery of where the quantum world ends and our classical, everyday world begins. The paradox wasn't meant to be a literal experiment, but a challenge to his fellow physicists. Explain this. To this day, the measurement problem and the true meaning of superposition are still hotly debated among physicists and philosophers. Schrödinger's career was also shaped by the turbulent politics of his time. When the Nazis came to power in Germany in 1933, Schrödinger, who was then a professor in Berlin, decided to leave. He moved to Oxford, but his unconventional personal life attracted some controversy in conservative English society. After a few years, he took up a position in Graz, Austria, but this was short-lived. In 1938, Germany annexed Austria, and Schrödinger found himself under the Nazi regime he had tried to escape. He was briefly in a dangerous position, but with the help of Ireland's Taoiseach, or Prime Minister Eamon de Valera, who was himself a mathematician, Schrödinger was invited to help establish the Dublin Institute for Advanced Studies. He moved to Dublin in 1939 and spent 17 happy and productive years there, becoming an Irish citizen. In Dublin, he continued his work not just in physics, but also in philosophy and biology. It was here that he wrote one of his most influential books, What is Life? In this slim volume, published in 1944, Schrödinger speculated on how physics and chemistry could explain the remarkable stability and order of living organisms. He proposed that genetic information must be stored in what he called an aporiotic crystal, a complex molecule that could carry a code. This idea directly inspired a generation of scientists, including James Watson and Francis Crick, who would go on to discover the double helix structure of DNA just a decade later. Crick himself credited Schrödinger's book as a major influence on his thinking. Erwin Schrödinger was a true polymath. He was a man who bridged the gap between different fields of knowledge, a physicist who thought like a philosopher and inspired biologists. He helped build the quantum world with his equation, and then spent much of his life questioning its bizarre implications with his famous cat. In 1956, he returned to his beloved Vienna, where he passed away in 1961. His legacy is immense. The Schrödinger equation is taught to every physics student and is essential for everything from designing lasers and semiconductors to understanding chemical reactions and developing quantum computers. And Schrödinger's cat continues to be the most famous and compelling illustration of the profound weirdness and wonder that lies at the very heart of reality. He challenged us to think deeply about the world, and that's a legacy worth celebrating. Thanks for watching. If this journey into the mind of a scientific giant made you pause, question, or see reality a little differently, take a second to hit the like button. It truly helps these stories reach more curious minds. If you enjoy exploring the hidden paths of science and the people who shaped how we understand the universe, subscribe to PastMinds. There's a lot more ahead. And if you want to continue this journey right now, make sure to check out our previous episodes, from the birth of the atom to the scientists who changed how we see matter, energy, and life itself. Each story is a piece of a much larger puzzle. We'd also love to hear from you. Which scientist should we explore next? Let us know in the comments. Until next time, stay curious and never stop questioning what you think you know.